20. Okay, so we got to really move. Okay, so that's basically the introduction for the concept of nervous system and inflammation. Okay? Is there any questions about anything I said so far? Okay. Okay, so I just want to go through a little bit of the science, okay? But this is a study that was done. Okay. And this part of the PowerPoint, I've just given you the first page of most of the science, so you can go and read them if you want. Oh, it's okay. So this is a study, and what I'm going to focus on is the vagus nerve.
Donc, il va avoir un intérêt sur le nerf vague.
And I'm going to show you how important the vagus nerve is for putting the brakes on inflammation.
Donc, il va montrer l'importance du nerf vague sur l'action de bloquer l'inflammation.
Okay, so these are two rodents that have bad karma. And anyway, in the sham, and then this is a vagotomy. A vagotomy means they cut the vagus nerve. Okay? So you can see the one that had the vagotomy is way more inflamed than the one that didn't. What they do is they basically inject a lipopolysaccharide, something that causes inflammation, into these poor animals' bodies.
Ils ont pris deux rongeurs, ils ont coupé celui qui se marquait vagotomy, ils ont coupé le nerf vague et ils ont injecté un polysaccharide pour créer de l'inflammation. Et on voit que les couleurs, dépendant du degré où celui qui a eu une section donc du nerf vague a plus d'inflammation.
Okay. So we're looking at, remember, nuclear factor kappa beta activation means what? Inflammation. It transcribes for inflammatory cytokines. So when they cut the vagotomy, when they cut the vagus nerve, they inflame more. That's what the red is. Remember, in inflammation, there's lots of blood flow and vasodilation and heat. Well, this is just a machine that is basically picking up the heat signatures in the body.
Les ondes rouges, vous allez voir, c'est un signe où il y a plus d'œdème, donc plus d'inflammation, parce que généralement, où il y a de l'inflammation, il y a plus un appel sanguin, un flux sanguin plus important.
Okay. So you can see that without a vagus nerve, right, you inflame. Okay?
You run with no brake.
You run with no brake. Your engine gets super hot. You can't control inflammation. I'll show you how. So the other thing that they did then, these are CD4 and CD25s, immune cells. Then what they did is they took the immune cell out, here's the control, and from the inflamed animal, they took these cells out, not the antigen, the immune cells, and they injected them into this particular poor animal here. So you can see, even though this had a vagus nerve, by putting in the cells from the activated animal, it caused inflammation.
Donc, ils ont retiré dans les cellules immunitaires CD4 et CD25. Ils l'ont réinjecté à l'animal. Puis même si l'animal avait son nerf vague, et on peut voir qu'il y a encore beaucoup plus d'inflammation.
Okay. What does that tell you?
Qu'est-ce que ça vous dit?
It means the cells are activated.
Donc, une activation cellulaire.
Remember, cells are just bags of biochemistry, basically, right? So you turn that biochemistry on in one biology, you can take them out, they're still activated, you inject them into the other biology, and it causes inflammation. Well, what does it mean? It means those cells are now little machines that make inflammatory cytokines. They're proteins.
Donc, à travers les cellules, même si les cellules sont retirées d'un mammifère à un autre, ils restent toujours actifs. Donc, pourquoi? Parce que souvent, les récepteurs, donc les CD4 et les CD25, ce sont des molécules qui sont encore actives. Donc, qu'est-ce que ça crée? Ça crée de l'inflammation.
Right? I mean, we talk... sorry?
C'est les CD4 qui...
Non, mais c'est... le mode de fonctionnement, c'est-tu comme un genre de mémoire cellulaire
Is it like the memory cells that you're talking about?
No.
So it's...
They're activated.
Donc c'est vraiment le système immunitaire qui est actif, puis de le déplacer d'un autre, il reste toujours actif.
Right. Memory cells have to be activated. Okay. They're predisposed to make antibodies because they've already been exposed to an antigen. These are already activated.
Donc ce sont des cellules qui sont déjà réactives, sont déjà activées.
So, we talk about inflammatory cytokines, but where do they come from? They're proteins. The cells,
Les
right,
cytokines pro-inflammatoires, ce sont des protéines.
right, make the cytokines which drive a certain type of inflammation, depending if it's Th1 or Th2.
Donc les cytokines sont pro-inflammatoires, cependant s'ils proviennent du TH1 ou des TH2.
Right? Okay, so we can give herbs and homeopathics and all these particular things to downregulate the genetics, so they don't make the cytokines.
Donc on peut donner plusieurs suppléments, plusieurs thérapies pour réduire justement l'inflammation à travers les cytokines.
Right? But we know that the vagus nerve is important because when we take the vagus nerve out or cut it, it causes inflammation, which means it allows for activation of these cells.
Donc le nerf vague, s'il est sectionné, donc il va avoir quand même une activation de CD4 et CD25.
Right?
Donc,
So does it make sense if you activate the vagus nerve?
Est-ce que ça fait sens d'activer le système nerf vague
It can act as an anti-inflammatory.
pour agir comme un anti-inflammatoire?
Does that make sense to you? Okay. Now, so this is literature importance of this pathway. So what I've just tried to show you is the vagus nerve is part of the anti-inflammatory pathway. We have cyclooxygenase, we have this, and that, and but they don't talk about it in all of the basic texts. Now they are. Now the vagus nerve is a huge nerve. Are you familiar with this nerve? Okay. Where does it go into? Your brain. And the whole theme I'm trying to say, you can activate the vagus nerve through different ways, but you can also activate it with your mind. It's just like a muscle. It takes time.
Le nerf vague étant un nerf un nerf le plus long dans le corps, donc il s'en va au cerveau puis il rejoint les organes. Donc pour pouvoir l'activer, on peut le faire par la pensée. Ce qu'il va vous présenter présentement, ce sont plusieurs articles scientifiques. Et si jamais vous voulez les avoir, j'ai pris vraiment l'essence de chacun des articles et je les ai sortis puis je les ai traduits en français. Donc après chacun, vous allez voir, j'ai fait des petits carrés, vous pouvez demander à Geneviève, ça va lui faire plaisir. C'est un ton fou de faire ça, mais ça va faire plaisir de faire ça.
Okay. So you need to understand this. In naturopathic medicine, we talk about removing the obstacle to cure. Have you heard of this? Removing the obstacle to cure? So in naturopathic medicine, we try and remove the obstacle to cure.
En naturopathie, ce qu'on essaie de faire, c'est qu'on essaie d'enlever l'élément qui va amener à la guérison.
Okay? So you can meditate all you want, but if you have a huge gut infection, it's very difficult to overcome that.
Vous pouvez
if you're a monk that hangs out in the Shaolin monasteries for 30 years, maybe. But for the average North American,
vous pouvez méditer tant que vous voulez, mais si votre fonction intestinale, la santé intestinale n'est pas bonne, mais vous pouvez méditer tant que vous voulez, il n'y aura pas d'action. Donc, on essaie d'équilibrer aussi les deux.
Okay, so the premise so far is I've showed you inflammation, how prevalent it is. We focus on cells, humoral, cytokines. Now I've just showed you how important the vagus nerve is. Okay? Is the vagus nerve parasympathetic or sympathetic? Right? So is this parasympathetic or sympathetic? What is the vagus nerve? Right? Okay? So what does that mean? Relaxation. That's why when people that have autoimmune disease, when they get all uppity and go into a sympathetic mode, it downregulates the vagus, which then allows for inflammation.
Dans les maladies auto-immunes, quand les gens s'emballent et donc augmentent leur anxiété, ça augmente le système sympathique et en augmentant le système sympathique, ça augmente justement l'effet inflammatoire. Donc, il va y avoir plus d'inflammation quand les gens sont en sympathique et non pas en parasympathique.
Yoga, meditation, eating well, psychotherapy, hypnotherapy, whatever it takes to a certain degree. Right? Don't go too pathological. But you still have to support the liver. You still have to support the gut to get all of the toxins out, to help. If there's lots of inflammation, the brain will be damaged. So I'll show you a couple of Viatrex products that will help with that. You still have to support the body, because sometimes if the body's too inflamed, they can't change their mind. And the reason they can't change their mind is because you haven't removed the obstacle to cure. Maybe they need, Nat Muir, 50M. Never well since seeing your dog get run over by a car. Like, who knows, right? You know what I'm saying? PTSD. I'm going to tell you something about.
Donc, il va vous montrer comment faire. Donc, avec la pensée, donc des outils, il faut toujours aussi penser à la naturopathie, donc supporter le foie et supporter aussi la santé intestinale. Vous pouvez donner plein de produits, mais souvent, c'est ce qu'il va vous montrer avec Viatrex, qu'il y a des produits qui peuvent être spécifiques pour le foie et pour la santé intestinale, parce qu'on peut mettre tout ce qu'on veut à l'intérieur. Il faut s'assurer que le corps fonctionne bien. Et il a parlé aussi en produit homéopathique. Il dit que si jamais vous voyez votre chien se faire frapper par une voiture, il dit souvent on peut travailler des remèdes homéopathiques, donc entre autres Natromur en 50 000 cas.
Okay? So I'll give you one more thing, then we'll go through the research, and then I'll do therapies. Do you know what post-traumatic stress disorder is?
Vous savez c'est quoi un stress post-traumatique?
Are they in sympathetic or parasympathetic? Yeah, like in a big way, right? So in the Journal of Psychiatry, May 2012, it talks about over 500 PTSD patients, PTSD, and they give them an ACE inhibitor, i.e. they decrease angiotensin II. Now, these are usually used for hypertension. So they're treating PTSD patients with an antihypertensive drug.
Donc, les patients qui ont été suivis pour un syndrome post-traumatique, ils leur ont donné des inhibiteurs de conversion de l'angiotensine. Donc, pour des problèmes post-traumatiques, ils les soignent avec des médicaments anti-hypertension.
Okay. Their blood pressure goes down.
La pression diminue.
They become happy.
Et ils deviennent heureux.
PTSD symptoms go down. Why? Because angiotensin, remember, angiotensin II causes inflammation in the brain.
Le mécanisme est que
Which,
l'angiotensine
causes all sorts of shit to happen. Thoughts and obsessive thoughts and sadness and right? So you see the angiotensin II in some patients causes brain inflammation and they can't get over their trauma.
Donc, le mécanisme, c'est que l'angiotensine 2 augmente l'inflammation au niveau cérébral, donc il y a une difficulté à récupérer d'un choc post-traumatique.
So you get the sympathetic, causes vasoconstriction, right, in the kidneys, right? Okay? What does this do? It increases angiotensin II, which then causes inflammation in the brain. So you can block angiotensin II with a drug, which is probably a good idea too, right? Especially if they're suicidal. Or if you get them into you stimulate the vagus nerve, it's not only decreases inflammation in the body, in the brain. When you decrease inflammation in the brain, how do you feel? Okay? So that's why in Kidney Plus and Infla, right, in Kidney Infla, these three things, Kidney Plus, Infla, and KI Infla, this is a sales pitch, all right? This is the Viatrex. This is why when I was giving them for the kidney patient, they started feeling better. They got happier. Do you understand? So expect that. So they may not, their kidneys still shut down, but they were happy. No, I'm kidding. Right? So what I'm saying, the organ function may lag behind, but they may start feeling better. And if that happens, this mechanism may be underway. It takes time for organs to heal, right? But as soon as you get that gut fixed and you decrease the inflammation, their depression and anxiety will start going away. And that's how you know you're on the right track.
Donc, ce qu'il va vous montrer, c'est que le système sympathique crée une vasoconstriction au niveau des reins, ce qui crée l'angiotensine qui augmente l'inflammation au niveau cérébral. Donc, si on agit sur le système sympathique en l'amenant parasympathique, ou, comme il disait, si on donne une petite plug à Viatrex, Kidney Plus, KD, which one is it? Inflam?
Yeah, inflam, in KI inflam.
KI Inflam, ça va diminuer l'angiotensine 2 et ça va diminuer l'inflammation au niveau cérébral. Donc, même si ces patients avaient des reins qui étaient finis, ils étaient très heureux d'avoir les reins finis.
Okay? Are we all okay? I'm going to finish up soon, okay? But I'm going to go through a bunch of slides, and I just want to show you the science behind it. And you could...
I took like some other parts, and I will try to read them in French what it is. Like,
oh, okay, okay. So this is just a vagus nerve and inflammatory reflex. This is the Nature Reviews of Endocrinology. And I put these up here so that if you're interested, you just Google this in, and the whole article will come up, and you can read it.
Donc, ce qui est important dans cet article-là, c'est le nerf vague, le système immunitaire, les réflexes inflammatoires. Il y a un lien entre l'immunité et le métabolique. Il y a un rôle de régulation dans l'homéostasie du métabolisme. Ça agit par le système immunitaire, la réponse pro-inflammatoire, par le biais des réflexes inflammatoires. Le trouble de la régulation du métabolisme et de l'obésité sont associés à l'inflammation chronique, donc des troubles de résistance à l'insuline.
Yeah, and what this really talks about, this one is inflammation and obesity, and how the vagus nerve controls all that. So if you weight loss isn't just about calories and all that, it's about stimulating the vagus nerve, because the vagus nerve controls the inflammation. Inflammation is a big part of the metabolic syndrome.
Donc en agissant sur le système du nerf vague, on peut aider les personnes à perdre du poids, donc c'est pas juste à propos des calories, donc les gens peuvent aider à réduire leur poids.
Okay, good. So here's another one, sympathetic nervous system and inflammation. Cholinergic anti-inflammatory pathway in dialysis patients. So this is where I get interested, because dialysis patients are very inflamed. So we give them all this stuff and it doesn't work. And no wonder they have anxiety and depression, because their vagus nerve is way down for certain reasons. Okay, so I'm showing you, and this is 2015. This is all very fresh, just picked.
Donc en 2015, dans ce journal de Clinical Kidney Journal, le système cholinergique agit sur la voie métabolique anti-inflammatoire chez les patients dialysés. Un rôle dans la modulation neuro-immunitaire.
Okay. Here's a neurostimulation of cholinergic anti-inflammatory for collagen-induced arthritis. So arthritis, for example, rheumatoid arthritis, autoimmune disease, they're starting to stimulate the vagus nerve for a treatment.
Donc la stimulation neurologique de la voie du métabolisme cholinergique sur l'effet anti-inflammatoire chez les rats souffrant d'arthrite du type collagénose.
Okay. Next one, sympathetic nervous system modulation of inflammation and hypertensive hearts. Cervical non-invasive nerve stimulation for prevention and acute treatment of chronic migraines.
Cet article-là, stimulation du nerf vague au niveau cervical pour réduire les épisodes aigus et chroniques des migraines à titre préventif associés à un trouble du sommeil.
Role of sympathetic nervous system in intestinal inflammation. Okay? Vagus nerve stimulation reduces inflammation in small intestinal mucosa. Another one. New approach to rheumatoid arthritis, autoimmune.
Donc, une nouvelle approche pour l'arthrite rhumatoïde, soulager l'inflammation par la stimulation nerveuse du nerf vague.
Okay, and that's stimulating the vagus nerve. So basically, you can read this, I won't do that. Another one, restoring balance of autonomic nervous system with innovative approach in treatment of rheumatoid arthritis. What they do, they put a little electrode on the vagus nerve, and they put the battery under the skin, and it goes, stimulates it like that. I mean, you know, a surgeon, right? If all I have is a hammer, everything looks like a nail. So you're going to do surgery. But you don't have to do that, okay? But you see, the inflammation in the nervous system, that's the whole concept I'm trying to... Okay, novel therapeutic targets in rheumatoid arthritis. So if you know anyone who has this very debilitating, horrible disease, but it's in the rheumatic. So you have spondylopathies and lupus, and all those diseases can be treated like this, with this. Treating inflammation, type 2 diabetes, obstructive pulmonary disease. What's this? Autoimmune diseases and its physiological insights. Talks about inflammation in the vagus nerve. Treating inflammatory pathways of cardiovascular disease. Okay? So you can see it's huge encompassing. So this is the vagus nerve, innervates the heart, the lung, the stomach, the liver, the spleen, the kidney, and the guts.
Vous pouvez voir que le nerf vague agit sur le cœur, les poumons, la rate, l'estomac, l'intestin et sur les reins.
And remember, the vagus nerve, you have afferents, so they go into the guts, right? And you have efferent, goes up into the brain.
Donc le nerf vague a une action afférente donc, qui se dirige vers l'organe, une voie efférente, donc retour vers le cerveau.
So what it's saying here, look, this is nuclear. Remember good old nuclear factor kappa beta? Right? This is your brain, well, a brain. Remember, there's inflammation in the brain too. This is stress. Remember, unless it's physical stress, it's all perspective. What might stress you might not stress me out. What stresses me out might not stress you out. It's how you view, it's a worldview issue. You know? So, but there's problems with that. Maybe you have inflammation in the gut or the lungs, or you're amped up, your sympathetic nervous system is elevated, so you're sensitive to all these things, right? Okay? The point being is this is just general. It's not in a context, so it's, you know. The point I'm trying to make is the brain connected to the immune system, which is relative to inflammation. Here's the vagus nerve. And it blocks nuclear factor kappa beta. What? How does it do that? I'll show you. Well, here's your brain stem, and you have your celiac plexus. So here's your vagus nerve. This is the efferent, though. Efferent goes down, afferent goes up.
C'est la voie efférente.
Okay? So, okay, cool. This is it, by the way. All this is about this slide here. Okay, so wake up. Okay? Celiac, here's your splenic nerve. Now, this is your spleen. What is your spleen? Your spleen has a lot of lymphocytes in there. Well, it's what they found in science is that the spleen or the vagus nerve can stimulate T cells.
Le nerf vague, vagus nerve?
Yeah, that's right.
Le nerf vague active les cellules lymphocytes T.
And it stimulates the T cell to release acetylcholine.
Donc, les lymphocytes T peuvent relâcher l'acétylcholine.
Okay? The acetylcholine then stimulates a receptor called the alpha-7 acetylcholinergic receptor.
Donc, active un récepteur alpha-7 quelque chose.
When this is stimulated, it blocks nuclear factor kappa beta.
Pour bloquer l'action de NF-kappa-B.
Therefore, it doesn't code for inflammatory cytokines.
Donc, il n'y a pas d'encodage pour la réaction inflammatoire.
Puts the brakes on it, right? So the cell does not become activated to be in an inflamed state.
Donc, cette cellule-là n'a pas une action pro-inflammatoire.
Okay? That's why when they cut the vagus nerve, this doesn't work, so then they take this cell, so then this cell becomes activated, right? And then they put it into another body, and it'll cause inflammation. because the cell is now coding for and making the proteins known as cytokines. Tumor necrosis factor, interleukin 6, interleukin 1, interleukin 1 beta. You know what I mean? Okay?
Quand on fait la section du nerf vague, quand on prend la cellule qui est au niveau du foie, on la réintroduit dans un autre organisme, il va y avoir une réponse inflammatoire parce que le nerf vague a été sectionné.
Okay? So you can either lipopolysaccharide, like from a bacteria, or another cytokine. All of these things increase nuclear factor kappa beta, which then code for inflammatory molecules and cause inflammation. Vagus nerve signals, basically stimulate this receptor, which then blocks nuclear factor beta. That's how vagus nerve is anti-inflammatory.
Donc le nerf vague envoie un signal au récepteur 7-alpha et qui va bloquer l'action de NF-kappa B.
Okay, so here is another picture, cholinergic anti-inflammatory pathway. It took about 50 years for thousands of scientists to make this one picture.
Ça leur a pris 50 ans à faire cette
In 30 seconds, we're going to explain 50 years of
Ça a
research.
pris 50 ans aux chercheurs à réussir à faire la diapositive que vous voyez là.
Okay, so here's your vagus nerve stimulation. It releases the acetylcholine. Now, in some instances, it doesn't have a direct effect. The vagus nerve may release norepinephrine, and the norepinephrine then stimulates cells to release acetylcholine. Acetylcholine is the main molecule, right? That's why nicotine, by the way, is anti-inflammatory also. Nicotine, acetylcholine, caffeine, they're all anti-inflammatory. They all have their nicotine's a problem though. It depends how you take it. I think the addictive thing is a bit of an issue, but other than that, anyway, so here's your acetylcholine. Anyway, this is just all the chemistry. I'm showing you it's very well known, is what I'm trying to point out. And it has anti-inflammatory properties because it blocks the coding for inflammatory cytokines.
Donc l'acétylcholine qui est sécrétée par le nerf vague ou la nicotine, donc la cigarette, peut avoir une action anti-inflammatoire.
Okay.
Et il mentionnait que la cigarette avait juste on avait juste créé des dépendances à la nicotine.
So it's called the anti-inflammatory reflex. So inflammation also has a reflex too. So we're coming to the end here, so hang in there. So what I'm trying to show you here, these are pro-inflammatory cytokines. So the efferent vagus nerve comes out of the brain, right? So it comes down, it innervates the heart, it innervates the spleen, gut, stomach, and liver. And the reason it does that, by the way, it also controls metabolism. That's another lecture. And it's a super boring lecture, so let's not talk. It doesn't matter. But if you're having problems with sugar metabolism and none of the drugs or anything's working, you have to think about the vagus nerve. Because
le nerf vague efférent agit sur les organes, mais agit aussi sur le contrôle du sucre. Donc, si jamais vous avez des problèmes avec des patients qui ont des problèmes avec leur glycémie, pensez au nerf vague efférent qui se rend vers l'organe.
That's okay. Efferent. Okay, now look. This is see this little thing? It blocks pro-inflammatory cytokines. That's why if you cut the vagus nerve in those little poor rodents, their guts inflamed, their liver inflames, and we can see it as heat coming off, right? Okay, so now this is the other thing you need to understand, is that there's also afferent vagus nerves. It goes up, and it comes off these organs too. So there's an afferent nerve, vagus nerve, that goes up into the brain.
Donc, il y a une voie afférente qui s'en va de l'organe vers le cerveau.
So if they have a gut issue,
Donc, c'est un problème intestinal.
and they're making weird chemicals,
Ils font des substances étrangères.
it can move up the vagus nerve
Il peut stimuler le nerf vague
and affect behavior.
et agir sur le comportement.
And it can cause depression
Il peut causer une dépression,
and anxiety
l'anxiété
and obsessive compulsive
et la maladie de
and psychoses if it's really bad.
psychose.
That's why some depression is in the gut. It's not in the brain.
C'est pour ça que des dépressions
Right?
sont dans l'intestin et non pas dans le cerveau.
Do you understand what I'm saying? Autism. That's why
That's
sorry?
Non, c'est bien.
That's why autism, we always initially look at the gut, because Clostridium bacteria that are in the gut, if they make too much of them, the Clostridium toxin is very neurotoxic. It goes up the vagus nerve and it causes inflammation and a decrease of glutathione in the brain.
Donc, on s'est aperçu que le Clostridium a libéré des toxines et qui peut avoir une action directement sur le cerveau par l'action du nerf vague afférent. Donc, ça libère des substances qui sont neurotoxiques.
Yeah, so that's why you look at some of these studies that are taking foods or all this other stuff out, and then they give anti-inflammatory stuff for the brain like N-acetylcysteine, CoQ10, resveratrol, vitamin C, and their brain irritation goes down. So they can sleep better, they have better behavior. Because what's happening if your brain's inflamed and everything's overwhelming, so they're like, right? They're blocking the environment. Could be heavy metals from vaccines, I don't know. But all I'm saying is we know that that's going on. So N-acetylcysteine, CoQ, all these things that increase glutathione will help the brain in autism. There's studies, just Google it. It's amazing. Google's amazing.
Donc pour l'autisme, si on agit sur... What did you say? N-acetylcysteine?
N-acetylcysteine.
N-acetylcystéine peut avoir une action directe sur l'autisme, donc en contrôlant et en calmant les enfants hyperactifs, parce que quand le cerveau est inflammé, les gens deviennent encore plus réactifs.
Yeah.
Donc N-acetylcystéine peut aider dans les cas d'autisme.
Yeah, so anything, you know how to do that. I'm just pointing out the concept, okay? So what I'm trying to say is, so therapeutically, increasing the vagus nerve can gather inflammation. So you can have all of these different issues going on, right? And what happens in medicine, they treat the gut, or they treat the heart, or the liver, or let's give them an antidepressant. It's the wrong way to do medicine now. And now you can understand. That's why maybe in these young kids under 18, it's not the antidepressants are stop the big gulps. You know, those 24 ounces of coloring and sugar. Have you ever had one of those? Holy shit. I had to go to bed. They're horrible. It's toxic, right? And then they eat sugar, so they get all these weird metabolites in the gut, causing brain issues. Then you already have an imbalanced neurotransmitter. Then what do they do? Serotogenic reuptake inhibitor. It imbalances it even more. Do you see? And then they go out of their minds. They can't get out of their state. So the only way to decrease their suffering is they kill themselves. That's a very bad thing that's going on. Right? Or they do alcohol, or they do drugs, or they do acid, mushrooms, all this other bullshit that's out there. When really, all you have to do is give probiotics and fish oil and a basic naturopathic diet. Now, the question is, you can answer this yourself, why don't they do that? I'm not a politician, but I think it's pretty straightforward. Okay? You excited?
Donc,
Okay, almost done here?
Donc, la diapositive, c'est thérapeutiquement, la stimulation du nerf vague peut aider à gérer l'inflammation et même agir à titre préventif sur l'inflammation. On sait qu'un dommage tissulaire ou une dysfonction pourrait nous amener à éprouver une sensation de bien-être. Il mentionnait que les adolescents, souvent,